everybody, today we're going to cover 3.7, the chain rule. So although this lesson itself is not going to take us very long to go through, the chain rule is a section that requires a lot of practice. There will be a lot of additional problem set work, and depending on the course that you're in, we will take more or less time going through the different types of problems that you could see with the chain rule. So at this stage, you've learned power rule, you've learned product rule, quotient rule, chain rules coming in, we've had trig. So there's a lot of different rules coming together, and I think that that's where the complication begins in this chapter, is when you have multiple rules within the same problem, and your job is to figure out which rule do I need to start with. And once you kind of get the plan going, then it's a little bit easier to follow through. Okay. So for our warm-up, I just want us to refresh function composition. So recall that f of FOG, fog, sometimes people call it, is the same as having this notation. Right? We have two functions, and we're being asked to input one function into the other. So the function that's on the outside of the parentheses, the f in this case, I refer to that as sort of the shell. Okay, that is the main function, and g is going into it. So I say take the shell of f, take all of the operations, but remove the input as you're starting the problem off. So the shell of f is saying take the square root of some input minus 3. Now this function composition is saying replace the x, or replace the input spot, with g of x, x squared minus 4. Okay. And then we simplify as much as we can. Sometimes there's nothing you can do, and in this case there's not really much. It just becomes x squared minus 7 under the square root. Okay, the next one, g of f of x. Now g is our shell, and f is our input. So the shell of g says square some input, and then subtract 4. This time, the input is the f function, square root of x minus 3. Here, we're able to simplify quite a bit more because we're squaring a square root, giving us just x minus 3, and then minus 4, so we have x minus 7. Okay. All right, so the chain rule, the reason we're warming up with this is the chain rule is allowing us to find the derivative of a composition function. So f of g of x prime is equivalent to f prime of g times g prime. Right, so we take the derivative of the outer with the original inner plugged in, and we multiply it by inner prime. So you have to be able to decide what is considered the outer and what is considered the inner. And that would be your f and your g. Okay, so out prime within original multiplied by in prime. So one way to think of the chain rule is differentiating from the outside in. Our first problem here is to find the derivative of sine squared x. So super important, I think we saw this one other time so far. Sine squared x is equivalent to sine of x quantity squared. Okay, it's not sine of x squared. We have to bump that squared, or whatever the exponent is, out. So we recognize what's the inside and what's the outside. So the outside function here is parentheses squared, something squared. The inside function here is sine x. Okay? We're working from the outside in. You can do this side work as much as you want, but you don't have to, of course. So I'll show it to you in this lesson, just so that you know. But as you get into the practice and you get better and better, you don't have to do the side work. So I'm going to show out prime is 2 times parentheses. That's the power rule. And in prime, the derivative of sine x is cosine x. So now my job is to put this back together following the chain rule. So the derivative then, d dx of sine x quantity squared, is equal to out prime with inner original. So out prime is 2 of something. The inner original is sine x. And then we multiply it by in prime, which is cosine x. Okay, so 2 sine x cosine x is the answer. The second one here is exactly the same thing, right? My out is something squared. My in is 2x minus 1. My out prime is 2 parentheses. My in prime is 2. So putting this back together, the derivative of 2x minus 1 squared out prime with inner original times in prime. Here I can clean this up quite a bit. So I have 4 multiplied by 2x minus 1. So I have 8x minus 4. Okay, now we're taking the derivative of cosine of x cubed. So here, the outer and the inner is different than the one that we saw before. Okay, now my outer is the cosine, my inner is the x cubed. So cosine of something, inside is the x cubed. It's sort of like saying to yourself, what's the last operation that would happen to the x or to the input? Right? The first thing that would happen would be I would cube it. Then after that, then I would apply the cosine to it. So you work in the reverse order. So out prime is negative sine something. In prime is 3x squared. Putting this back together, y prime would then be equal to negative sine of x cubed multiplied by 3x squared. You can clean it up a little bit by putting the 3x squared out in front. So negative 3x squared sine of x cubed. I like to put the 3x squared out in front for a couple of reasons. I think it does look better, but the other reason is sometimes we make the mistake of combining the x cubed that's within the sign with the 3x squared, and that's something that would definitely not be allowed. Okay, y is equal to the square root of x to the 4th plus 1. Decide what's the outside, decide what's the inside. So my outside, sort of that big overarching or umbrella function sometimes I refer it to, is the square root. The inside is the x to the 4th plus 1. Now it's helpful to think of the square root as an exponent, as a rational exponent. So it's something to the 1/2 power. So my out prime would then be 1/2 parentheses to the negative 1/2. And my in prime would be 4x cubed. So my answer, putting it together, y prime is 1/2 x to the 4th plus 1 to the negative 1/2 multiplied by 4x cubed. A couple of ways to simplify this, kind of depending on the direction of the problem. If there was a follow-up question, you could bump the negative exponent down to the denominator, but you don't have to here. But I would at the least combine the 1/2 and the 4x cubed to have 2x cubed, x to the 4th plus 1 to the negative 1/2. Okay, so I'm going to leave these 3 for you to try on your own, and we can do them in class together. Okay. The first 2, you definitely have examples that are very, very similar. The third one, I do want you to try to figure out what's the outside, what's the inside. Okay. Pause the video. Don't let me reveal it to you, but I am going to say it in just a moment so that everybody at least has the correct direction to head on these. For some reason, E has always been the hardest one to decide what's outside, what's inside. So when you have an exponential, the exponential is the out, e to the some power, and the in is the cosine t. Okay. All right, and we'll go through these in class. All right, so here is our first example where we have chain rule in combination with another rule. So in this case, we have the quotient rule. So you have to decide what comes first, right? So here, we would have to set up the chain rule first, and that's when we would come across our quotient rule, right? Quotient is inside of chain. So my outside function is tan something. My inside function is x over x plus 1. Here's where I highly suggest to start kind of setting up one rule at a time, right? And then derive that next rule. So my out prime is secant squared something. My in prime is where I'm going to kind of pause. I'm not going to actually derive it because it requires a quotient rule. So I'll do that next, after I fully set up my chain rule. So y prime would then be secant squared of x x plus 1 multiplied by this quotient rule that I know I still have to do. Okay. So now that I've identified I have a quotient rule, I have an f and I have a g that I have to... Okay, so now we're going to complete the quotient rule. So we have to identify what's the numerator, what's the denominator, what's the f, and what's the g in the quotient rule. So my x is my f, and the x plus 1 is my g. So remember, quotient rule is f prime g minus f g prime divided by g squared. So y prime equals secant squared of x over x plus 1 times f prime is 1, g stays, minus f stays, g prime is 1, divide by g squared. Okay. Oops, I didn't mean to put that last squared. Okay. Cleaning up that quotient rule just a little bit. So y prime equals secant squared of x over x plus 1 multiplied by, in the numerator I have x plus 1 minus x. This would cancel, and I would just have a negative, a positive 1 up top. Over x plus 1 squared. You can move that to the front, you can leave it there, but please make sure you don't make the mistake of combining it with the input of your secant squared. So the x... Okay. Last example for this lesson. Here we have multiple chain rules. Okay. Again, we're working from the outside in. We do one step at a time. As we get better at this, I will show you how to do this without any work, but ultimately you're always working outside in. So the very first outer is going to be that big square root. So something to the 1/2 is the very first outer. And the very first inner is 1 plus another square root. Okay. So my first line of work, I'm going to show that I'm going to derive my first outer, which becomes 1/2 original inside to the negative 1/2. And I'm going to just notate that I still need to derive my inner. Okay. So now, as I'm deriving my next inside, that's where I come across a second chain rule. And that second chain rule is right here. Okay. There's two terms in my original inside. That one that stands by itself gets derived independently. It's a constant, it will go to 0. So let's show that. So we have a 0 there. But now I've arrived to my second chain rule. All right, so again I have a square root, and I have an x squared plus 1 for my inside. So when I'm doing this chain rule, right, outer prime is a 1/2 inside to the negative 1/2, and inner prime is 2x. Okay, I can clean this up a little bit, right, and I'm going to go ahead and do that. I'm going to first show 1/2 1 plus square root x squared plus 1 to the negative 1/2. And then I'm going to combine this 1/2 with the 2x in this set of parentheses, so I just have an x squared plus 1 to the negative 1/2. And the only other thing I can do is I can take the 1/2 and the x and put them together out in front. Everything else is under a square root, a negative square root technically. Okay, and that would be our final answer. So chain rule by itself is not too bad, right? Outer prime, inner original times inner prime. It starts to get complicated as multiple rules are within the same problem. So we're going to have tiered practice in this section where we focus on first just chain rule by itself, Then can we do it with a product or quotient rule? And then can we do it with multiple chains and perhaps also some products and quotient rules? Okay.